probability discrete random variables. Is that right?
Yes,
Correct.
lesson 4.
Yep. And let's see. Troy is not here right now. He is delivering his baby, which we feel is a valid excuse. And did anybody have any questions with the lesson 4 homework that they'd like to discuss now?
No, until I start the quiz, and I don't know what I'm doing.
I guess we can go to the quiz now. What do you guys think?
Yeah, I think I don't have any, I mean, once we do the quiz, then I'll know if I have questions, but let's just do it.
All right, lesson 4 quiz. Let's go. Kendra, is that good with you?
Okay, she's still.
There was so much hype, and now there's not any hype.
Yeah.
Okay, we can just go over it with her when she gets back. So,
Okay.
question 1 and 2 should be true.
Yes. Okay.
And then I will start with question 3. Human blood can be classified into one of our basic types, O, A, B, and AB. The proportion of people in the population of the United States with each of these blood types is summarized in the following table. Question 3. The blood types and the proportions given in the table above define a probability distribution. Well, it gives a proportion.
I say yes, and my reasoning is because if you add all of the proportions up, it equals 1.
Right.
And probabilities have to be between 0 and 1.
So you can read it as saying 45% has O, 40% has A, and so on.
Yeah. Yeah.
I would agree. What do you think, Minerva?
Yeah, I agree with it.
Cool. Who's got question 4?
I can read it. What is the probability that a random selected person in the United States has type O blood? Round to decimal 2 places.
45%.
So let's give all your answers as decimals. Don't give it as percents.
Okay.
That was in the information above.
Right.
So, yeah, so it's 0.45.
That works for me.
Okay.
Yep. Oh, fine.
All right, Minerva, you got question 5?
What is the probability that a randomly selected person will not have type of blood? Round to 2 decimal places.
0.55.
Yes. That's what I got.
All right. Use the following information to answer the next 2 questions. Carolyn Willis and her colleagues conducted a study in which dogs were trained to detect bladder cancer. The dogs were trained to lie down next to a specimen derived from a bladder cancer patient. Tangle, one of the dogs, demonstrates the identification of a specimen. 7 bowls containing urine were lined up in a random order. 6 of the samples were from patients who did not have bladder cancer. 1 of the samples came from a person identified as a bladder cancer patient. If the dogs guess at random, what is the probability that they will correctly identify the dish containing the spectrum from the bladder cancer patient? So it would just be 1/6, right? But we have to put that in decimals.
Yes, so that would be 0.16.
1/6. 1/7?
Wait, it'd be 1/7, wouldn't it? Because it's 1 out of 7. Hold on, I'm confused now.
Oh yeah, it would. Yep. 6
Okay.
that don't and 1 that does.
Yes. So yeah, so it'd be 1/7, right?
Which is 0.14.
4.
0.143, because we have to round to 3 decimal places.
Okay.
Oh, okay.
And we're rounding because it's 0.1428.
Yep.
So if we round up, it's 0.143.
So the other answers are fine, right? Because they're even 0.55 and 0.45.
Yeah. Yep.
And we are supposed to run to the second anyway, though.
Another.
One on the other one.
Yeah.
Yeah, you're right.
Yeah.
Okay, cool. Question 7. Who's got it?
I'll read. In a combined total of 54 trials, the dogs correctly identified the specimen from the cancer patient 22 times. It is very unlikely that the dog would do this well by random chance alone. Which of the following statements is most appropriate?
I don't like either of them.
Yeah.
They got it less than half.
Yeah.
One out of every 7, and there's 57 trials. That's pretty good.
Okay, let's see. Which of the following? It is very unlikely that the dog would do this well by random chance alone.
But is it strong evidence?
That's 357 polls.
I don't
So
know.
I wonder if they want us to look at the numbers instead of that last sentence.
I think it's the strong evidence that the dogs can detect bladder cancer, according to the information, because it's about 378 times 8, 22.
I'm stumped on this one.
I think it's a trick because it gives you data that kind of suggests that it's not that great, and then it says, oh, it's unlikely that the dog would do this well by random chance.
Yeah. So this provides strong evidence?
That's not strong.
But half of it are
Less than half.
correctly, right? So 40% are not.
Guys, which question are we on?
Question 7.
7.
Seven.
You
Yeah.
guys are crazy.
We're stuck. And then Kendra, after 7, we can go back to 1 again if you like.
Oh, I wouldn't want to keep you guys on. I can go back and watch the video.
Okay. You sure?
Yeah, I would feel bad. Think so.
No problem. So we're stumped by 7 because it seems like a trick question, and then the numbers kind of like less than half of the time they detected the cancer. But then it says it is unlikely that the dog would do this well by random chance.
There's little evidence that dogs can detect bladder cancer. I wonder if does this go back to like that like P factor?
P factor, get it?
Is that what it was called?
It was a urine test.
No. Oh, that's funny. Like, wasn't it like if it's less than 0.5%, then you reject the null? I don't know, guys.
I don't want to miss this problem because it's 1 out of 15 or 13.
Can't we take the quiz twice?
Yeah, I guess we can. Well, okay, then we get 2 options. I'm going to pick this provide strong evidence.
I'm going to pick the strong evidence.
Final answer.
That's my final answer.
All right. Kendra, do you want to read number 8?
Sure. Use the following information to answer the next 3 questions. M&Ms are small chocolate candies. The M&Ms website previously indicated that in the United States, the distribution of colors in a bag of plain M&Ms is given in the following table. If you reach into a bag of plain M&Ms, what is the probability of drawing a red colored candy? Round your answer to 2 decimal places.
So just do 0.13, right?
Is everybody's green color all colored out?
Someone smudged it.
Okay.
Yeah.
Well, so do we have to, don't these have to equal 1?
Mm-hmm. And I'm guessing in the next question they're going to ask us to find what green is.
Yeah, to calculate what green is.
Oh, okay.
Oh yeah, there it is. Number 9.
You guys are smart. All right. So the answer is 0.13 then, yeah. Okay. What is the probability random selected candy is green? So it's 12.
I got 0.16. Is it 12?
Wait,
What was it?
let me try
I
again.
got 0.1.
Wait. I got none of those.
What?
Oh, maybe we have different like proportions. Like mine
Oh, yeah.
mine says brown is 0.13, yellow 0.14. Is that what everyone else's says?
Yeah,
Yeah,
I got
so-
0.1.
Never mind then.
So yeah,
My
0.16.
first one, I fat fingered it, so.
Let me try this again. 20.16. Yep, sorry about that.
Nope, you're good. All right, Minerva, do you want to do number 10?
Yes. What is the probability that a randomly selected candy is not green?
Oh my gosh.
0.84, isn't it?
0.84, yeah.
So it would just be
Yes.
all the other ones.
Yeah.
0.84.
Yeah.
All right. The ACT scores of students admitted to a medium-sized public university in the Western United States were taken from capex.com. The following summary statistics were calculated. Half of the observations are less than or equal to what number? What?
Review question. So do we take the median's the average, right?
Median's a middle number.
Oh, okay.
Mean is the average.
So then wouldn't
It'd be 24
half,
then.
yeah, half less than 24, less than or
Yep.
equal to 24.
There you go.
I'm gonna have a hard time remembering those two. I always get them mixed up.
I do too. And then when they use mean and average, like interchangeable.
Yeah.
The way I remember it is that mean is mean because you have to do more math, and it's very mean.
Huh. All right, I'll try and remember that. That's a good one.
Who's got 12?
Okay.
So wait, on the question 11, we just write less than?
Less than or equal to.
Yeah.
I just wrote number 24 in the answer.
Because 24 is the median, which is the middle number.
The middle.
Oh, okay.
Yeah.
So 24?
Yep.
Yeah.
Okay, so I'll read are we on number 12? Based
Mhm.
on the information on the table above, the top 25% of the students scored above what number?
So that would be
Q3, right?
3. Yeah, that's what
Yeah, so that'd be 27.
Yeah.
So sounds like a low score to me. Oh no, it's an ACT score.
Yeah, that's not bad.
Nope.
I mean, I got higher than that, but like whatever. I'm just teasing, guys.
All right.
I can read 13.
Okay.
Which of the following statements is not one of the 3 rules of probability? Probability that an outcome will not occur is 1 minus. I really don't like these descriptions. My notes were like better, but let me get my notes. Okay. Probability is a number between 1 and 0. That's correct.
That's correct, yeah.
Probability is high, then the probability is positive. So I think that number 3 is false because because the probability wouldn't ever be negative.
Yeah, it can't be negative.
Yeah.
No, yeah, it can't be negative. So the third one.
Yeah.
Okay.
Let's see. Okay.
Perfect.
Yeah, because the complement rule is the very first one.
Yeah.
All right, let's see what we got.
Oh, we get to.
Kendra, are you sure you don't want us to go over those questions?
Well, have you guys already submitted? Like I don't want to just get like the answers from you, so I was trying to read them really fast.
I can read it to you if you want. I haven't submitted yet. It's the same thing we just did.
Oh, okay. Give the blood types and proportions given in the table. The blood types and the proportions given in the table above define a probability distribution. True. Wait, does it equal 1?
Yep.
Okay, yeah, I'm gonna go with true on that one. What is the probability the random select person in the United States has type O blood? 0.45. These are pretty easy.
Yeah, they are.
Yeah.
Okay. What is the probability the random person will not have? So 1 minus 0.45, 0.55.
You got it. And then I think we're caught up.
I've got to do 6
So-
really fast.
I submitted mine, and on question number 7, we were right.
We were right?
Strong evidence. Yes. Strong evidence that dogs can detect bladder cancer is the one.
That's so weird. I don't agree with that, but okay.
Well, maybe your dog doesn't detect cancer.
He definitely doesn't. He just lays around.
You need to get a different dog, dude.
He's just going to be out on his mission all day, sniffing people's urine.
Oh gosh.
I still don't understand that one. But
correctly identify the dish. So for number 6, is the probability just, is it not? Oh wait, maybe I'm looking at this wrong. Hold on. Tank 1 of the dogs demonstrates the identification of a specimen. 7 bowls containing urine were lined up in a random order. 6 of the samples were from patients who do not have cancer. 1 of the samples came presented. Dogs guess random. What is the probability they will correctly identify the dish? Oh, it's 1 in 7, isn't it?
Yep.
Okay.
so I just realized, you guys, that let me go back to it. Hold on. I think we were supposed to do. Are we supposed to? Let's see. In the preparation for home paper, it said that part 2 you will fill this part out during your group presentation session.
I saw that too.
So I think we need to do that.
Where do we
after-
submit it then?
Oh, it's super easy though. I mean, it's just 2 questions.
Yeah, it's really easy.
I mean, I already
Well-
did. Like,
I did the whole graph of it, and I don't know. What do I submit the whole graph or the graphic? The chart, I'm sorry.
for part 2,
Uh-huh.
I isn't it just asking?
It's just asking about the dice for the preparation assignment
Wait,
Are you
where is
looking at
that?
number 5?
at number 4.
L04 individual preparation, that one?
Yeah.
Yeah, lesson 4.
During your group.
Download the preparation assignment and answer key, use part 1 to take notes, that part?
Yeah. Yep. And then part 2, it has a picture of like a purple die.
I do not see that.
Die. I do. You don't see
Is
the
it-
die?
Is it in the document?
Yeah,
Yeah.
it's in the second page of the Word document.
Hang on, let me share my screen with you guys.
Okay.
How do you do that? Show your screen.
If you like hover over your screen, there's some options that come up, and on the left-hand side, there's one that says Screen Share.
Okay, can you guys see? Wow, look at that infinite loop. Okay,
Wow.
so I downloaded the document, the assignment,
Yes.
and then where's the dice?
Well, let me share my screen. Oh, that's the answer key, isn't it?
Is it?
I mean,
Yeah. I
Mine-
think. Here,
mine
share.
does not look like that.
Let me see one sec. Nope, that's the answer key.
Let me show you mine.
Okay,
Share. So this
Yeah, that's
was
what. Yeah.
what
Mine was
in the
like-
world?
problems, and then it has this.
Why do I have
That
a
one.
different
Yes.
document?
Do you have a Mac?
I do.
Well, there's your problem. I'm just kidding. I have no idea.
Shots fired. Okay, what's the last question in your document?
Calculate the probability of not getting a number greater than 5.
Yeah, we have 2 totally different documents for our L04, lesson 4 individual preparation.
Weird.
Is
I don't
that
think-
lesson 5?
No, mine was 4.
Go back to share yours again.
Okay, hang on. Can you see it?
Okay.
Okay.
So I'm going to click on this, right?
You're gonna click on the individual preparation. Yeah.
Right.
And then download the preparation assignment. Yeah.
Okay, and then this is it. There it is. What the heck? That was weird. Okay. All right. So we want to do this now?
Yeah, let's do it.
Wasn't it just the last two questions, right? Like 5 and 6?
Yeah. Yeah,
Okay.
it's just the last two.
I'll read 5. An 8-sided die has 8 possible outcomes for each roll, 1 through 8. Calculate the probability of rolling a number greater than 5. I got 3 8s.
Yep. And so to express that as a probability, it would be 0.375.
Yes.
Correct.
Okay.
Okay, and then number 6.
So we're not,
What's that, Minerva?
are we going to submit that one how? Or we just do it together?
Doing it on this recording to show that we've done it.
I don't think we submit it.
And
Well,
so
I guess-
Okay.
Okay, so number 6 says calculate the probability of not getting a number greater than 5.
that would just be 5/8.
5
Yeah.
8s. Yeah.
Or 0.625.
5. Yeah.
What does it mean to be random? Ask the weird kid at my high school.
Okay, so then we're good with that.
Yeah. Do we want to move
Yes.
on to lesson 5?
Yeah.
Yeah.
All right. Lesson 5 group quiz.
Okay, hold on. Let's see where we at.
Hold on. Yes, yes. We need
Everybody
to.
just hold your horses.
You're like fast going. You have a Mac, that's why, right? I don't.
I don't blame the computer. It's really just my personality.
Oh, you're so humble.
Okay. This one's going to be hard. This is the stuff that I didn't.
I feel like the second lesson every time has been like a lot harder to grasp sometimes.
Yeah.
The first lesson, I didn't even know what planet I was on, so.
Oh yeah, well, you were like a week behind.
Right.
How's the hurricane cleanup going?
4.
It's good. Everything's just really, there's debris everywhere.
That's good.
All right. I am in the quiz. Let me know when you guys are ready.
I'm in. I'm ready for number 3.
I'm loading. Hold on.
Make sure you get number 1 and 2 correct.
And I thought I had good internet.
We are not judging you.
Well, at least I'm not in a hotel.
Yeah.
Wait, where are you, Minerva?
Right? Now I am in my home. I live in Layton, Utah.
Oh
Oh,
yeah,
okay.
I'm in Orem.
Oh, nice.
I'm not in any of those places.
I was in DC last week, so it was like 10 o'clock over there.
That's right.
Wow.
Hey, I'll be right back. I'm going to grab a drink.
All right.
Okay.
Okay.
Okay, I'm back.
Okay, so is everybody on quiz 5?
Ready when you are.
Okay, I'll just read question number 3.
Okay.
And just like as a reminder, above the information, it just says do not round until your calculation is complete.
Perfect.
All right, so question number 3 says the total area under a normal distribution curve must equal what?
1.
1. I got 1.
That's what I was gonna say.
You got to round that. I'm just kidding.
Round.
1.000.
Yeah, exactly.
All right,
Okay.
I've got question 4.
All right.
Under certain circumstances, a normal distribution curve can drop below the x-axis. I don't know about that.
I'm pretty sure that's false.
It always rests on the x-axis. It can go below the y-axis.
Yeah, but it says it always lies on or above the horizontal axis, which is x, right?
Mm-hmm.
Yeah,
Okay, so false. That's what I got.
that is what I got as well. Okay, a normal distribution curve is symmetric. True?
Yeah, I think so. Wow, look at those drawings. Those are great.
True.
I don't judge anybody for writing on the computer. It's hard.
Oh, yes.
All right, Minerva, you got 6?
So which of the following elements of the figure represents the z-score? C.
C.
Which also means yes.
Oh my god.
Sí, señor.
Okay, which of the following elements of the figure represents the probability that the z-score will be greater than 1? Is it none of these represents the probability that it'll be? Whoa, wait, greater than 1.
It would be
So,
B, wouldn't it?
B.
B.
Sorry, I misunderstood. Yeah. Yes. Right? We're saying B?
Yes.
Yes.
Okay. Cool.
Yes. Is it my turn again?
Sure.
Yes.
Question 8. According to the 68, 95, 99.7 rule, because I know what that is, what percentage of the data from a bell-shaped distribution will be within 1 standard deviation of the mean?
68.
Yeah, 68. Are the percentage such as 42 rather? Yeah, it's 68.
Oh, write your answer as a percentage. Yeah, 68.
Are you putting the percentage sign as well?
I'm not.
No. Because it just says as a percentage such as 42.
Oh, right. Yep, there it is.
Oh, this one has 18 questions.
You said we put the percentage number? No, right?
Mm-hmm.
No.
No, I didn't. I just put 68, no percentage.
Okay, thank you.
Where's the keys?
Okay, so I'll read number 9. Suppose that z-scores come from a standard normal distribution. Use the normal probability applet to answer this question. What proportion of the z-scores will be placed or will be between -1 and 1? Give your answer as a decimal.
Is it 0.6827?
Okay, so what percentage of the z-score between -1 and 1?
Yeah, because it's 68%, right?
Mm-hmm.
Or 0.68. That's kind of what we answered above.
Yeah.
So 0.683?
0.683. Yes, that's what I'm gonna put.
Okay, how do you get the 3? Where are you guys getting 0.6?
0.27.
What?
It was,
So like, I'm sorry.
no, you can go ahead.
If you like click in the areas and stuff, it'll change the. So like if you unselect the 2 blue ones and select the middle one, it says 0.6827, and then you just have to round to 3 decimals.
Oh, okay, I see it now. Okay, so 0.683.
Yeah.
Mm-hmm.
Okay, I see that now. Now I have to find my quiz again. Hold on. Shoot. Okay, so 0.683. Okay.
Okay, I'm lost. Hold on.
Do you have that normal probability applet thing up, Minerva?
I do, but I don't know how to enter the number here. It's not working for me.
Oh, well, so like if you just click in the different sections, it'll turn it like blue or white.
So I put there the 1, -1. On the C-score? Are you talking about the C-score?
Let me share my screen.
Okay.
So like, do you have a thing that looks like this?
Yes.
So if you just like, you can set this, you know, wherever you want, but for I think the first question, it's 1 and -1. So if you just
So I
unselect
need to
and
move.
select this middle part, it tells you right up here like what the area of this section is. Does that help at all?
Yes. So is that 1.8413?
No.
Wait, sorry, what?
No? Goodness thing.
Are you on question 9?
Yes.
Okay. So this one's saying like if you set the whatever the
Z score.
proportion of scores, yeah, if you set it between 1 and -1, so like that's where I've got these lines here is 1 and -1, and then I've got this area selected. It gives me the total area up here. So we rounded it to 0.683, but now it's different because I've moved my thing. Oh, look, so I can do -1 and 1. So then
that's the one that
yeah, so then it's just saying round to 3 numbers, so it's 0.683. Does that make sense?
Yes.
Okay. I'll stop sharing.
Okay. Got it. Sorry,
All
guys.
right, whose turn is it for 10?
Okay, I'll do that one. Suppose that C-score comes from a standard normal distribution. Use a normal probability applet to answer this question. What proportion of the C-score will be between between -2 and 2? Give your answer as a decimal, accurate to 3 decimal places.
So I got 0.955.
Yeah, that's it. Same thing we just did, different numbers.
Yeah.
I got 0.977.
If you type in down at the bottom like -2, it'll make it exact.
Okay.
Do-
That's what I did.
You did?
Can you share your screen?
Yes. Where's my- Yes. Sorry.
That was beautiful.
There you go. 772. Can you see it?
No.
No.
Oh,
Oh.
there you go.
Yep.
Point.
What in the world?
772. Huh.
Point.
Can you refresh the page?
That's weird.
-2.
Right.
I'm confused. Try to reload that page and see what it does again.
Oh, you know what? Your right hand corner is selected as well. So like
Oh,
unselect.
yeah.
So just beyond to the right. Yeah, there you go.
Oh, okay.
Okay. Got it now.
We were so confused.
Thank you, guys.
Guess what the next question is? It's -3 and 3.
Mike, what'd you get?
I got 0.997.
Same.
That's what I got too.
What did you observe? Oh, hey, look at that.
Go
Do
shower.
the values match the rule?
Yeah, I was gonna say it's the rule.
Somebody needs to go shower.
Oh, that's my family. No.
Daddy.
Oh,
Tell me what's that.
Okay, you need to go. You can take
so they
that.
match the rule.
Yeah,
I want to go to bed.
I know. Me too.
All right. Oh, this question 13 does not look fun, but let's jump in.
Okay.
The amount of protein that an individual must consume is different for every person. There are solid theoretical ideas that suggest that the protein requirement will be normally distributed in the population of the United States. The protein requirement is given in terms of the number of grams of good quality protein that must be consumed each day per kilogram body of weight. I'm not going to read that. The population mean protein requirement for adults is 0.65 grams. Yeah, okay.
Or
And the population standard is that right there. What proportion of the population have a protein requirement that is less than... Okay, I'm lost.
Okay, so I don't think we need to worry about the actual, like, all those letters. We just need to worry about the 0.65 and the 0.07.
So the standard deviation is 0.07 and the mean is 0.65. So picture a curve with the highest point around 0.65, right?
Where's P? Picture this.
Okay, so this is the one.
Okay, wait. So is this like 0.65? Is that what we're saying? Can you guys see this? Is that right or totally wrong? Oops.
So what? Oh, wait, I have the screen. Hang on. Yeah, like that.
Yeah, and then the standard deviation is 0.07, right?
So you can go in either direction, 0.07.
Well, that's very minuscule, so I'll exaggerate that. Quick, what is 65? It's
0.65 minus 0.07.
All we need to do is put 0.60.
So it's 0.58. That's the next one.
Isn't it? Is it 8? It's 0.58?
Yeah, 0.58.
I cannot do math right now.
7.
That's amazing. What proportion of the population have a protein requirement that is less than 0.6? This is not that helpful. Percentage. So hypothetically, let's say that's 0.6. This percentage of population. Can we still use this thing?
Was applet? Yeah.
That one, or we can use the
Oh, sorry, I'm sorry.
the Z.
Okay, where are we at? Okay.
The Z4. Population standard. Population.
Whoever said this was going to be harder was absolutely right.
Yeah. Okay. So, let's see. Oh, you know what? What we need to do is we have to do the, I think we have to do the formula.
Yes.
We need to do 0.07 equals. No, I don't know. I have no clue. This is where I think I know it, and then I do it, and then I don't remember.
I'm trying to figure that out too.
Oh, you know what? We have to figure out the Z-score first.
The Z-score, yes.
don't we?
Yes. The population.
So yeah, so we have to figure out the z-score of this first, I believe.
60 minus.
I've got to pull up the textbook.
Nope, that didn't do it. Sad day. We were doing so well.
So 0.60 minus 65 equals entre 0.07 equals. Is it minus 0.714? Wait, hold on. Let me put that one on.
Okay, what's our
What is our thought process here?
I'm trying to find it in the textbook. Okay. So
I got 0.5248.
I got 0.5. Nope, that's not. Nope.
So
That's not
okay, do you take 0.65 minus 0.6 and then divide it by 0.07?
What is the 0.6?
What?
a portion of the population?
Yes. What proportion of the population have a protein requirement that is less than 0.6?
I did 0.6 minus 0.65.
Okay.
That's what I did too. And you divide it by 0.07, which is a deviation.
Yeah, which is the z point or the z-score.
Okay,
Then you get
And then you put it on.
negative
start.
0.71.
Oh my goodness.
You did 0.6 minus 0.65 divided by 0.07?
Yes.
Can you have a negative
Correct.
z-score?
Yes.
Yeah. Yeah, because it's then you just put it on the left-hand side and it becomes.
Oh yes. Okay. Yeah.
So what did you guys get? Because I got like negative 0.71.
4.2.
That's correct.
Yeah.
Put that one right there, and on the top we'll give you 0.525.
Wait, what?
Huh?
Are you? You're plugging that into the applet thing?
Yeah.
Yes.
So in the negative z-score. Oh, okay, that makes sense. Negative 0.77142.
And then you guys are just putting the opposite in the positive one?
It does it automatically.
No, it up to you, but it says that you have to highlight the. You
The one
have to
below
highlight below it. Yes.
So 0.2376.
2376. Correct.
0.2376. Yeah, that's what I got.
Okay.
And so what do we have to round that to?
To 3 decimal places.
0.238.
0.238. Wow, guys, that was a stretch.
Yeah, there we go.
That is more than 60. Okay, so then more than 60, we'll highlight the middle section and the far right section.
Yeah.
Okay.
0.762.
Yeah, 0.762. Protein requirement that is less than 0.7. Okay. Well, now that I know how to do it. Okay.
So then now we just do 0.7.
So it's 0.2. Wait.
Oh, it's the same. It's the same thing but positive.
It's the middle and the left one, right?
That is less than. Oh yeah, that makes sense. 0.762.
So is the answer to number 14, is that negative?
No, it's
Okay.
positive.
Same answer then.
2.
Yeah, it's the same answer.
So
Is that what you got?
15 and 14 are the same answer, right?
Yeah, that's what I got.
Yeah. Because, yeah.
Find the probability the randomly selected person will have a protein requirement that is between 0.6 and 0.7. Remember that to find the area between two values, shade to the left of each of the z-scores. So you can calculate. Oh my gosh.
Okay, so yeah, so we got the z-scores,
Mm-hmm.
which were the same, right?
Right.
Yeah, they were.
Okay, so then
One
it would
plus
be
one.
0.
Well, so it says, remember to find the area between two values, shade to the left of each z-score you calculate, and then subtract the smaller area from the larger area. Does that just mean that we're left with the middle area?
Hold on, I have
We just have to take the 2 z-scores. We take off the 2 z-scores and then we minus it. But we cannot do that one on the applet together. It has to do it separately.
Probably the random selected observation will lie between the two values. Well, so is it not, let me share my screen. Is it not just this middle section?
No.
Because it's saying,
I think it's going to be 0, you guys.
I was thinking 0.
Because you subtract z1 from z2, you subtract the smaller one from the larger one, but they're both the exact same, so you're going to get 0.
Oh, yeah, you're right.
Now, I could be totally off, but that's...
okay.
I don't know. I have no idea what I'm doing here.
So what do we think it is?
Okay. To find the area between two values, shade to the left of each z-score you calculate, and then subtract the smaller area from the larger area, making sure your answer is positive. What the? Okay. Let me try some.
Find the area between 2 values, shade it to the left, and then subtract the small area from the left. Which one is possible?
Well, I mean, this is what I mean. This is what I'm doing, but I don't know if it makes that much sense because it's saying like, remember that to find the area between the two values, shade to the left of each z-score. So this is the first z-score, and this is shaded to the left, and this is the second z-score, and this is shaded to the left. And it says you subtract the smaller one from the larger one. So this area I just did 5248 minus this area 2376 and got, where'd my calculator go?
But when you shade to the left of the second z-score, you would include the second one as well, wouldn't you?
Yeah, maybe. That would make sense. So then do you just subtract this from itself and you're left with the middle?
That sounds about right, though.
Yeah.
That's what I'm getting to.
So it says that the applet cannot calculate the probability between two values directly.
I'm dead.
Oh gosh. Where are you getting that?
Yeah, so it says
but
the
if you-
applet in the textbook, it says the applet does not allow us to find the probability of being between two values directly, but we can calculate these probabilities with the applet as follows. Oh, so you know what you need to do is, yeah, so you find
the 2 C's and then that higher from you, yeah, the higher from the lower.
yeah, which I'm going with 0.
That's what, yeah, according to if the last 2 questions, because you get the same answer, it comes back to 0.
Yeah.
But it just doesn't seem Right, that nobody would have it.
There would be a 0 probability that a randomly selected.
Person would have it between those values. Those are pretty normal values, right?
Yeah.
Oh, wait a second. Maybe they're not.
Well, let's see.
Because that's on the high end of the spectrum. That's the very high end of the spectrum. If we're considering all the way down to the negative.
Yeah.
I don't know.
Bitch, I have to go soon.
I
Let's just go on and then we can come back to those.
Yeah. Find the 35th percentile for the protein requirement for adults. I don't want to.
I don't
So
either.
now we just put 0.35 up in the top of the probability output, right?
Mm-hmm. Wait, what?
I don't know.
Oh, that doesn't. I don't think that gives us
No, it doesn't.
any useful information. 35th percentile.
Between negative 0.71 and 7.71.
The protein requirements for adults. Oh gosh.
Well, hang on.
Oh, so you know what we need to do? So, okay.
Let's add 0.35, right?
No, okay. Hold on, where are we at? So you put in the probability app, you put in 0.35, you find the z-score, which is 0.385, and then what you have to do is you have to plug that into the equation. So you have you kind of work it backwards. So you have 0.385 equals, and you're trying to find x minus 0.65 and divided by 0.07.
What does that give you?
I don't know. I haven't done it yet.
So x minus divided by 0.07.
I got 0.67695.
Just a sec, I'm catching up.
I got 0.68, so I guess the same thing.
So x equals 0.6745. 6745, is that what you got?
I got 0.676. Let me do this. Okay. So I got 0.07 times 0.385.
Isn't it 35? Where's the 385?
The z-score. If you put in 0.35, you have to get the z-score.
I still don't know where you're getting 385.
If you go to the probability applet,
Yeah.
you put in the area up at the top is 0.35,
Oh,
and then you get the z-score is at 0.385.
mine says 0.454, but what part of the section do you have?
Oh, you know what? I have, okay. What part should I have highlighted?
Well, so if you're just putting 0.35 into the top of the thing, shouldn't that tell you? Well, now my thing's not working, so I don't know.
It shouldn't matter with the z-score. Well, no, you know what? Let's see.
Is 0.35 the z-score?
No, 0.35.
It gives you the z-score.
It does?
She was saying that we have to plug that into the applet.
Yeah.
Wait.
Where are you plugging it in?
Here. At the area 0.35, at the area.
It gives you a z-score of 0.454.
It works.
It gives you, okay, so obviously I'm doing something wrong. What does it give it? 0.454?
Mm-hmm.
Well, it depends on what section you have highlighted. because if I change it from the middle to the right and type in 0.35, then I get 385. But if I highlight the middle section and do 0.35, then I get 454.
Oh, yeah.
That's weird because the z-score shouldn't change, should it? It should never change.
I don't know.
Maybe these individual sections have individual z-scores.
Because my z-score is not changing. Let me, you know what, I'm going to close out and let's see. Let me go back and get it. Yikes. Okay. So if I put 0.35, okay. Let's see.
There's a meeting tonight for the Greenlaw posted.
Yes.
Hey, I found it in the textbook. So, okay, so it says first we need to find the z-score that corresponds to the percentile using the normal probability applet. So it says click on the areas under the curve until only the areas left of the positive z-score are shaded blue. So that would be the left and the middle section.
Okay.
And then it says type the desired area or percentile in the box at the top of the graph. So we want 0.35. And then the z-score corresponding to this area will be displayed in the bottom right box. Hey, you had it right. I'm sorry I doubted you.
No, it's good. I don't know what I'm doing, but
Take a victory lap.
woohoo.
So you're going 0.385 divided by
No, 0.385. No, 0.385 times 0.07.
Yeah.
Point zero what?
Plus
7.
0.07, which is the standard deviation. Wasn't it the standard deviation?
Yeah.
And then add the mean, which is 0.65.
Yeah. So 67695 or 677.
Yeah.
Yeah, that's what I got.
Is that the answer we're looking for?
Yeah, that's the answer.
Yay, 0.677. Find the 80th percentile. All right, well, now that I know what I'm doing.
So you want to make sure you click both.
Right.
So I got 0.842 for the z-score.
As did I.
Are we still on question 17, right?
No.
We got 0.677 for that one.
Yes. Okay.
Okay. And then I got 0.709.
That's what I got.
For the 80th percentile?
Yeah.
Okay. Yay, we're done.
What was that? I'm sorry, my calculator just crapped out.
0.709.
Yeah, I got the same thing.
I'm gonna submit.
We were going to go
me-
back to another one.
Oh, we were? Okay, hold on, let me go back.
Wait, what were we going to go back to?
One that we didn't do because we didn't know. I can't remember now which one was it.
Oh, yeah, it was either we thought it was 0 or something else. Well, let me see.
Oh,
Let me see
number
if I
16.
got it right, and I'll tell you.
You're going to be the sacrificial lamb?
I missed one, but it wasn't the one we thought.
So it's 0 then, right?
No, I did, for that one, let me tell you how I got that answer, wherever I put it.
We're talking about number 16?
Okay. I think that's it. Yeah, I got that one right. So what I did, let me put my, oh gosh, my thing is gone. What was it? It was like 0.714.
Yeah, 0.76. Wait, what was it?
I think it was 714.714.
Yeah.
So I just did like the thing said to highlight both the left sections of those lines and then subtract the smaller one. So that's really what I did. 7624 minus 2376 and got 525 and I got that one correct. I did, however, miss question 17.
0.525
Yeah,
to 16. 17 is not 0.677,
it is not.
but we got 18 correct.
That's correct. So figure that one out.
That's weird.
So let's go through that math again then.
Sure.
All right, let's see.
0.677.
Yeah, I get the same thing.
Are we maybe it says it's the one in the right box though, so I don't know. I was gonna say maybe we're supposed to make the z-score negative to begin with
Oh, you know what? I wonder.
because there's nothing filled in that middle one.
Maybe. You know what? Let me try that one. Try that.
.623.
I have 6236.
0.62305.
Yeah, that's what I got.
Okay, I'm going to try 0.623.
Okay.
Okay, I'm submitting.
I am too. That was right.
Yay.
Okay.
I'll just go back and redo it.
Do you want us to just tell you the answers for the other questions then?
Hey, that sounds nice.
All right, question 1 and 2 are true.
Okay, hold on, let me get back into it. Do we want to stop recording at this point?
Yeah, hang on. All right, this concludes our broadcast.
Thank you.